Question 5, we have equation of a curve y equals to 2 cos x, and we have to sketch the graph of y is equals to 2 cos x from x minus pi to positive pi, and then state the coordinates of the point of intersection with the y-axis. Now, the easiest way to sketch any trigonometric graph is we just substitute the values of x into the calculator, and we'll get the y coordinates. So substituting x equals to minus pi, so 2 cos of minus pi in the calculator will give us minus 2. Substituting, well, x equals to 0, we can get 2 times 1 will be positive 2, and substituting pi again into the equation, positive pi will get minus 2. Now we know that the x coordinates are from minus pi till positive pi, and the y values are ranging from 2 till minus 2. So at x minus pi, the value is minus 2. At x0, the value is positive 2. And at x pi, the value is minus 2 again. Simply joining the 3 points, we'll be able to sketch the graph of cos. All right. Now we have to state the coordinates of the point of intersection with the y-axis. We can see that the coordinates for the point of intersection with the y-axis are 0, minus 2. Now in the next part, it says that the points P and Q lie on the curve and have x coordinates x 1 upon 3 pi. So let's say if this is 1 of pi upon 3 or 1 upon 3 pi, this is point P, and the other x coordinate of Q is x is equals to pi. So this will be the point Q. We have to find the length of PQ correct to 1 decimal place. Now, to find the length of PQ, we need the y coordinates of both of these points. We know that Q has a point pi comma minus 2. To find the y coordinate of P, we can just substitute the value of x into the equation y is equals to 2 cos x. So substituting pi upon 3, the x value will be 2 times half, that will, the y value will be 1. So we know that the coordinates of P is pi upon 3 comma 1, and the coordinates of Q is pi comma minus 2. Now using the distance formula, we'll get the distance of PQ, which will be square root of x2 minus x1. So we can write it as pi minus pi upon 3 whole squared is equal minus plus minus 2 minus 1 whole squared. Substituting this in the calculator, we'll get PQ is equals to 3.7. Now it says in the next part that the line through P and Q meets the x-axis at H and the y-axis at K. We have to show that the value of H is equals to 5 upon 9 pi, and we have to find the value of K. Now, to attempt this question, first, let's understand what the question is actually asking us to do. So let's say we have the 2 points, and the line through those 2 points is intersecting the x and y-axis at the points P and Q. So it is intersecting x-axis at the point h comma 0. So the point h has coordinates h comma 0, and we have the y-axis at k, so k will be 0 comma k. Now to find these values, first we need to find the equation of this line. Now we know that the line passes through the points P and Q. So we can use this equation y minus y1 is equals to m into x minus x1 to first find the equation. Once we have found out the equation, we can just substitute the values of h and k. So for h, we'll substitute y equals to 0 to get the h value. And for point k, we'll substitute x equals to 0 to get the k value. To form the equation, we have to first find the gradient. So the gradient will be given by m is equals to y2 minus y1. So minus 2 minus 1 divided by pi minus pi upon 3. So the gradient will be, so simplifying this, we'll get minus 9 upon 2 pi. We'll form the equation. So this will become y, and we can use any of the points. So I'll be using the point P in place of y1 and x1. So this will become y minus 1 is equals to minus 9 upon 2 pi times x minus x1. So this will be x minus pi upon 3. Now we know that the point h is h comma 0, and the point K is 0, comma K. We have to show that h is 5 upon 9 pi. So in the same equation, we'll substitute y equals to 0. So this will become 0 minus 1 is equals to minus 9 upon 2 pi times x minus pi upon 3. Simplifying this, we'll get minus 9x plus 9 pi upon 3. And the 2 pi will multiply with minus 1. So that will become minus 2 pi. Solving for x, we'll get 9x is equals to 9 pi upon 3 plus 2 pi. So 9x will become 3 times 2 is 6. So 9 plus 6 is 15 pi upon 3. And then 15 pi upon 3 divided by 9 will become 3 ones are 3 fives are. So we have the value 5 upon 9 pi. To find the value of k in the same equation, we'll just substitute x equals to 0. So we'll write y minus 1 is equals to minus 9 upon 2 pi times 0 minus pi upon 3. Simplifying this, we'll get y minus 1 is equals to minus 9 upon 2 pi times pi upon 3. That will be positive 9 pi upon 6 pi. Pi and pi will cancel. So y will be equals to 9 upon 6 plus 1. And the value of y will be 9 plus 6 upon 6, which will be 15 upon 6, which is 5 upon 2. So this is the value of k. And this was the value of h that we had to prove.